The universe has a way of reminding us that there is always more to discover, even in our own cosmic backyard. Just when we think we have a complete map of our immediate surroundings, a new traveler appears. Recently, NASA confirmed the existence of a small object named 2025 PN7. This isn't just another asteroid passing by. Scientists are calling it a quasi-moon. It's a special kind of celestial companion that has been quietly following Earth for decades. This discovery opens a new chapter in our understanding of the space right outside our window, offering a fresh perspective on the dynamic and ever-changing nature of our solar system. When you hear the word moon, you might picture the large, bright orb that graces our night sky. However, 2025 PN7 is quite different. It is incredibly small, especially when compared to our primary moon. Scientists have estimated its width to be somewhere between 18 meters 36 meters, or roughly 60 feet, 120 feet across. To put that into perspective, imagine a small office building, a large house floating in space. It is more like a giant boulder than a planetary body. This diminutive size is one of the main reasons it remained hidden from us for so long, a tiny needle in the vast haystack of space. Its small stature also means it is very faint. Unlike our moon, which reflects a great deal of sunlight, 2025 PN7 is a dark object that reflects very little light back toward Earth. This low reflectivity, combined with its size, made it an exceptionally challenging target for astronomers to spot. Because of its modest size, 2025 PN7 does not have enough mass to pull itself into a spherical shape. The most captivating aspect of 2025 PN7 is its unusual orbit. It is not a true moon in the classical sense. A true moon like ours is gravitationally bound to its planet, circling it in a stable, predictable path. Instead, 2025 PN7 orbits the Sun, yet its orbital period is almost identical to Earth's. It takes roughly the same amount of time, 1 year, to complete a full trip around our star. That orbital resonance lets it stay close to Earth for an extended period, making it appear to follow us from the ground. This special orbit is why we call it a quasi-moon. It's engaged in a complex gravitational dance with the Earth and with the Sun. The Sun is the dominant gravitational force keeping it on track, while Earth's gravity gives it a gentle nudge, making its orbit wobble and twist. From our viewpoint, 2025 PN7 traces a strange, corkscrew-like path around Earth, even though it's actually orbiting the Sun. Think of two cars in adjacent lanes on a vast circular racetrack, one sometimes pulling ahead or falling behind, yet staying close. One of the first questions that comes to mind with any new near-Earth object is whether it poses a threat to our planet. In the case of 2025 PN7, the answer is a clear and resounding no. Astronomers have meticulously calculated its orbit and have confirmed that it will not come anywhere near a collision course with Earth. This object is a peaceful companion, not a looming danger. Its path is well-defined and predictable, and it maintains a very safe distance from us at all times. The Moon orbits Earth at an average distance of about 384,000 kilometers, 239,000 miles. In contrast, 2025 PN7 stays much, much farther away. At its closest point, this quasi-moon comes within about 4 million kilometers, 2,500,000 miles of Earth. That is more than 10 times farther away than our own moon. If the Earth were a basketball and the moon a tennis ball 30 feet away, 2025 PN7 would be a much smaller ball over 300 feet away. The discovery of 2025 PN7 is a story of modern technology and careful detective work. The object was first officially identified on August 2, 2025, by the Pan-STARRS 1 observation system. Located atop the Haleakala volcano in Hawaii, Pan-STARRS is one of the world's leading facilities for detecting near-Earth objects. It consists of a powerful telescope with a massive digital camera that repeatedly scans the night sky. By taking a series of images of the same patch of sky over time, astronomers can create a time-lapse where stars remain stationary, but closer objects like asteroids and comets appear to move. It was during one of these routine surveys that the faint moving speck of 2025 PN7 was first flagged by the system's software. The discovery was then confirmed by human astronomers who began tracking the object to determine its orbit. The global astronomical community gathered more observations to refine its trajectory and confirm it was a new object. A review of past records revealed images dating back to 2014, hiding in plain sight for years. The discovery of a new quasi-moon is more than just a neat piece of cosmic trivia. It holds significant scientific value. For astronomers and planetary scientists, each of these objects is a small but precious clue in the grand puzzle of our solar system's dynamics. So far, we have only confirmed a handful of quasi-moons orbiting Earth. With 2025 PN7 now joining this exclusive club, scientists have another example to study, compare, and contrast. Each one helps refine models that predict how small bodies move, especially under Earth's complex gravitational influence. One major benefit is testing and improving our tracking for near-Earth asteroids. The better we can predict their paths, the better prepared we'll be if one is ever on a collision course. Quasi-moons provide perfect real-world test cases with subtle gravitational effects. By comparing behavior to predictions, scientists fine-tune software and build confidence. They also offer windows into asteroid composition, origins, and distribution near Earth. NASA's JPL provided precise tracking and noted these objects reveal how dynamic and interconnected our near-Earth environment is. The discovery of 2025 PN7 is exciting because it adds another member to Earth's small but growing family of known quasi-moons. Before this find, there were 7 other confirmed objects. With the addition of 2025 PN7, the count stands at 8. Each one of these celestial companions follows a unique path and has its own story. Some, like the quasi-moon Kamo-Oalawa, discovered in 2016 as HO3, have been with us for nearly a century and will stay for several more. Others may have much shorter or longer tenures as our orbital partners, sometimes lasting for thousands of years. All of Earth's known quasi-moons are transient visitors. Their orbits are only temporarily stable, and over long periods, they are perturbed by other planets and transition to new configurations. Despite their proximity in cosmic terms, extensive calculations show no risk of collision for the foreseeable future. Their predictable paths mean ample warning if anything ever changed. Beyond their scientific value, quasi-moons like 2025 PN7 could play a practical role in exploration. Because their orbits are similar to Earth's, it takes relatively little energy for a spacecraft to reach them, land on them, and potentially return. This makes them ideal targets for robotic missions, or even human missions, as low-cost testing grounds. A spacecraft could rendezvous, map the surface in high detail, and analyze its composition. Such a mission is less complex and expensive than going to the distant main asteroid belt. Sample return could reveal the building blocks of planets. These objects could also serve as waypoints or resource depots for ambitious missions. Some asteroids contain water ice that can be split into hydrogen and oxygen to make rocket fuel. While we don't yet know the composition of 2025 PN7, each accessible object brings these concepts closer to reality. Perfect places to test landing, mining, and long-duration operations. In summary, the discovery of 2025 PN7 is a wonderful moment for science and for anyone who looks at the sky with a sense of wonder. We have learned that Earth is accompanied by a new, tiny companion, a quasi-moon, confirmed by NASA after its discovery by the University of Hawaii. This small rock is only about the size of a building. It is not a threat to us. It maintains a safe distance, at least 10 times farther away than our own moon. It travels in a similar orbit around the Sun. Its presence is a gentle reminder of the complex, dynamic nature of our solar system. This quasi-moon has likely been our neighbor for over 60 years, and is expected to stay with us until around 2083 before continuing on its own path. Its discovery was made possible by the Pan-STARRS survey, and confirmed by digging through archival data. It helps refine orbital models and methods crucial for planetary defense.